Well, we want to welcome everybody. Welcome to the La Space Academy, and you are the ones that made it in. We congratulate you. As Dan said, we have a record number students that are joining us tonight, and we want to welcome you. We had a waiting list of over 100 that we're still waiting to get in, and we had our cap for our auditorium holds 500, and we're just about right at that cap. So welcome. My name is Sherry Klug-Boonstra, and you have met some of the team. We'll be talking about the team here shortly. But we want to welcome you to this very special type of NASA project. This is actually part of the Lucy mission, which you'll be meeting the principal investigator of that mission shortly as our keynote speaker tonight, Hal Levinson. And we want to just give you a little bit of background on what this academy is about. You all saw the application. Obviously, you applied, and so you know somewhat about it. But this is actually an effort by NASA and the Science Mission Directorate specifically to really think about how we can train NASA's future workforce, the exploration group that will be coming up in the near future into the workforce, and how could we get them started in a more accelerated way. And so we helped mold that idea of a brand new type of workforce development. This academy is the actual result of that. And we wanted to be able to not just have it in singular locations, but actually offer it to the whole US. We have over 40 states and Puerto Rico that are here tonight. We want to, again, we're going to be helping you see who's here. We have some kinds of things that we're going to be participating in, and we want to again bring that with you. So Dan, would you go to the next slide, please?
Yes.
So just as a reminder, and again, this was in the application, but that's maybe been a little while ago since you actually applied. This is really our way of being able to engage undergraduate science and engineering students in a type of an immersive activity that's going to basically be putting you in the same kinds of problem solving and teamwork that you would be on a NASA mission team. We are in the mission process. We are part of the mission teams. I've been on mission teams for over 20 years myself. And of course, we have the Lucy team that is the backing up the type of ways that we're, again, helping highlight what it is we're leaving the experience with you. But we're paralleling this in real stuff. And so we want to bring to you the best talent to help do this training over this 12 weeks. Academy 2 is the follow-on. If you successfully go through Academy 1, then you are absolutely invited to Academy 2. We have our first Academy 2 starting earlier this week. And we have several hundred students already going into that to continue their project and to actually optimize things that they've been working on. But we want to immerse you into this type of environment in terms of the way NASA works, the way NASA does missions. A big foundation for this activity that we're doing tonight is teamwork. As I went out to talk to mission teams across different NASA centers, as I went out to aerospace and the people that are involved in the space ecosystem, the number one thing that came back is we need people that know how to actually work on teams and can optimize that experience. And so a lot of the practice we're going to be putting you through, the paces we're going to be putting you through, the problems we're going to throw at you really are project-based in the sense that they are within the team environment. And you're cross-disciplinary. You'll see that in a minute in terms of who's in this room with us tonight. And we want to help mold you towards what that environment is going to be like ahead of time, so you have practice in that, you learn the jargon, you learn the different protocols and things that are expected. And again, it's professionalizing you in a way that maybe you don't have, that advantage of your university, or you don't have ways to learn that. So with that, go ahead in the next slide. So this is the Academy team that is with you tonight. And again, we are lucky enough to have Hal Levinson, who's the principal investigator of the Lucy mission, which you're going to hear about tonight in terms of the background. And again, we have a whole cadre of people, scientists, engineers, We have evaluators. We have people, and again, we're very serious about how this is working as we develop this model. And we are iterating on the fly. I mean, we learned a lot in Academy 1 this last fall, and we have taken those lessons learned already and rolled them into making this even better for you. We are your consultants in terms of your projects. We have scientists and engineers, people that will help you, again, get up that learning curve, understand things, and we have a lot of wealth of expertise here within this group. We will be using this time also. You see that we have 3 evaluators here on this slide. We are very serious about learning how things work. We will be pinging you to say, you know, tell us about your experience and the kinds of questions that you answered on the application. All those things are helping us understand who you are and how we can meet your needs, and better yet, how we can get you into the marketable position of that talent pipeline that NASA is going to be looking for. Okay, next slide. So these are some of the things we want to, again, help you understand from the beginning. We want to help you learn how, within a mission environment, within things that we don't know yet, when we're going after big challenges and trying to solve things on the fly as we do our exploration across this vast solar system. You know, how do the real mission scientists and engineers approach and problem solve these kinds of things that come out of left field? And so it's a kind of ways that we're going to be bringing you the top talent within the environment of NASA, and helping you understand what these people are doing in everyday types of things. So we're not going to give you an agenda in terms of here's the list of all the people that are coming, because with our agenda, we have things we want you to be instructed in, but these are very, very busy people. And as we go after these top talent types of people that we want to come in as our presenters, we have to work around their schedules too. So things are very fluid in terms of us being able to get our people here before you. And so we work with their schedules, and we schedule by the week in terms of bringing the people in, knowing, again, the agenda, the types of talking instruction and talking points and things we want you to learn. You're going to also have the chance to think about preparing, going from concept through design to testing. This is some of the things that we are running you through, where we're going to be announcing teams next week in terms of who's actually in, and there's a little asterisk there that I'm going to come back to. So you'll learn who your teams are. We're going to bin you across time zones. We have probably represented here at least 5 time zones within this cadre of students that we have in Academy 1 for the spring. So we won't throw you into, you know, disarray in terms of saying you're a West Coast person on East Coast time trying to meet with people. We at least understand that. We're at a university ourselves. We understand the cadence of the university, and we try to work across the kinds of things that we know are upcoming. We're going to have you also learn mission-based software to do part of your project. We're going to have instruction in different aspects of what it's going to take for you to be successful. So we want to bring those kinds of things into focus, but better yet, practice and be able to give you feedback on how you're doing in terms of your project. Academy 1 in the fall went fantastically. The types of products that were turned out by these student teams, I actually took them to NASA headquarters and showed them across other, you know, venues that we had, that we were intersecting with a lot of the NASA hierarchy in terms of the mission people and the Science Mission Directorate. They were astounded at the type of caliber of the materials that you were producing. So we have high expectations, and we will help you get there. Everyone in this academy should be able to reach the highest goals. That's our goal, is to help you actually become those pre-professionals and soon to be professionals in a way that's going to be very unique. Okay, go ahead, Dan. So we're going to be, like I said, assigning you to teams. There are expectations. This is an all-in type of course. We have 12 weeks. We'll be checking to see, and Dan, we need to have another Mentimeter on when spring break is for everyone. If you would create that, that would be great. we want to make this tempo again to where you can be in. We expect you to be very inclusive and active in your teams. We have ways that we're going to be contributing to that in terms of giving you tools and such that you'll be able to actually have that communication going on. And communication, we found with this last academy especially, the very highest types of achievements were the ones where the teams were active, they were communicative, and they were really all in, like I said. So we're going to help you get to those points and give you the tips that's going to help you also get there. So we expect you to be at all of the sessions. If you cannot be, you have, if it's an excused absence, you need to get in touch with Dan. We do take roll every single session. We count and see who's in, and we pay attention to that. So we want to make sure that you're here. We check how active you are with your teams. We have ways to do that as well. We're trying to help you be as productive as possible. And as I mentioned, we have over 100 students waiting, still hoping that they could get in, and we do have follow-on academies too. If this is something that you are not going to be able to be present, you are not going to be able to be communicative with your team and contributive, then maybe another session would be better for you, and you can let Dan know. And summer is coming up. We just opened the summer session that's already filling, and then we'll do another one next fall. So again, be mindful that we're expecting you to be part of this community and part of these teams and this project as very participatory. And then also, we want to remind you, and Dan already has, we expect you to be professional in all your communications and actions. This is like you're coming to work at NASA. We expect you to have respect for your teammates. There is, just as you would be, at a professional job, that's the type of communication we expect you to be with your team. This is something that you are practicing the real stuff, and we expect you to actually exhibit those kinds of behaviors at all times. And so whether it's your team meetings or other kinds of communication in the chat, we expect that professionalism to start kicking in now. We also are making sure that you understand that there are internships available. We have, Lucy is sponsoring internships, and we do have, if you are part of the Academy, 1 or 2, you are eligible to get into this very unique pool, a small pool compared to a lot of other internships, and you can apply. And that's on the LaSpace homepage, laspace.asu.edu. And you can actually apply for summer internships. That deadline is coming up January 25th. So I would take a look at that and make sure that as long as you're not a graduated senior at the end of this is for undergrads, you're not a graduated senior by the end of this semester, then you're still eligible to go ahead and put that in. So I would encourage you. Internships are amazing. I used to run the internships across all 10 NASA centers for undergraduates, and I would highly encourage you to make sure that you're applying for internships and have those done, whether it's here with the Lucy internships, whether it's NASA internships, or the different companies that are, again, within the space ecosystem. All
Sherry,
right.
I'd like to also add in terms of the internships, everyone here will be receiving an email. I've scheduled it to go out, but you're not going to get it until the end of tonight's class. I don't want to distract you. And so you'll be receiving the email with all the details for the internship, along with a link that'll take you directly to apply.
Okay, thanks, Dan. And that's a very good point. All right, next slide.
Well, next up we have our Mentimeter, our very first one. We want to hear from you guys. We're going to do a little bit of interactivity. Like we've mentioned before, this is not a program where you can just watch a recording. We want you to participate fully. So we're going to participate in an activity called Mentimeter. We're going to use a tool that we want to hear from you. So I want you to pull your phones out, everybody. So here's a class that we're going to encourage you to use your phones, or you can use your web browser as well. And I want for you to go to the website www.menti.com. You'll be prompted to enter a code. The code is 789751. Once you get to that point, we want you to answer this question: what do you hope to gain from the LaSpace Academy experience? Why are you here? What are the 3 things you have? Actually, you can enter 3 top things that you want to gain from this experience. So once you start that, and we at the very bottom right of the screen, we can see how many people have participated. So currently with us in the room, we have at least 400 of you. So we want to see everybody participate. So we're already seeing some responses coming in. We see experience is definitely right up there. The larger the word is on the screen, the more of you are typing those words. So that seems to be the one thing that most of you want here is experience. We see knowledge, teamwork. I see. Sherry, what other things do you see that stand out to you?
Well, I see leadership in there. I think that, the connectivity, connections, teamwork. And I think, we're interested because we're going to be doing this at the end as well to see what did you gain, and maybe there will be some different things in here. You're coming into this cold and with expectations, but we want to kind of see where those expectations are. And I think right now, the experience, the knowledge, and the teamwork are the biggest bounces on this word cloud right now. And I think you will absolutely be getting those. And again, we look forward to bringing to you the really interesting but also instructional kinds of people that are going to be additive into your project. We have a very exciting project that's planned for you. It's something that is current within the NASA project, types of things that they have on their board that they need to actually solve, some of the things that they're working on. And we want to bring you into that very relevant type of situation. And that's what we're going to be doing. And we'll be announcing that next week. Okay. So we're up to 417. I think we have about 450 students in-house right now, Dan. Mm-hmm. So, all right. So we're seeing this. We're going to let this go for just a couple more minutes here. Experience, knowledge, teamwork are the ones that really, and we're going to go through and harvest what's in this cloud as well to kind of make our own understanding of your contributions. This is important to us for us to understand this as a baseline. So we appreciate the way that you're contributing. And we're going to be doing this from time to time. We have a lot of ways that we're going to be picking your brain about things. And then you're also going to get some time with our speaker tonight, with Hal, with Dr. Levison. So you're going to have your own questions put out there as well. So with that, why don't we go ahead and we'll let that continue. You can keep going. If you haven't done it still, just keep going. We're up to about 4:30.
And we actually have one more question in terms of finding out who's in the room. So who's joining us here today in terms of your discipline. So we want you guys to get an idea, and not only you, but our guest speaker, Hal, as well, to get an idea of how many engineers are in the room, for example. So we're going to transition to that here. I'll give you 5 seconds. Everybody type in your final responses for this one. In 5, 4, 3, 2, 1. All right. Oh, wrong. That was the one I was working on, spring break. Sorry. We'll get back to that. So who's in the academy? Share your field of study. Exactly the same code that you'll apply on your screen. It should automatically shift over. We see 50 of you have already entered in, 79% currently of engineers. We've got 22% of scientists right now. And again, these numbers that we're seeing here, this is live data that's coming in. So really excited to bring you real-time data from your peers, and you get a chance to really interact and so different from a regular online class where you just watch a video. We want to make sure that every single week we're bringing you the opportunity to engage with each other and with us.
And you will be becoming familiar with all of the folks that are in the room, and you'll seeing them from week to week. And again, you'll be working on teams with some of these people as well. So, this is important to us. We want this to be cross-discipline experience, and you're going to actually have different people on your team that will have some of that different experience as you tackle these projects. So we'll just let this accrue for just another minute. And we've got our chat masters. I think the chat is zooming by in terms of what people are doing. So, and it's and again, we're lumping engineering. There's a lot of EEs and MEs and aerospace and everybody else in that category as well. Same with the science disciplines. We have a whole array of science folks that are with us, and so we'll have a chance to look at, as we cobble these teams together, we're very mindful about what class standing, whether you're a freshman or through senior, what experience you have, what your discipline is. We actually bring those teams together very mindfully. Okay, why don't we go ahead and go on, Dan?
Sure.
Good.
We can go ahead and get out of this now and
let's go ahead and let's bring Hal in.
Yep.
I think that's time to bring in the big guns. Oh, I don't like, I'll take the gun part out of it. We'll bring in the top talent. So welcome, Hal. How are you tonight?
I am doing great. How about yourself?
Oh, we are excited about this group that's here tonight. So, and then thank you very much for giving your time.
My pleasure.
All right. So we are ready to launch into your great presentation about Lucy. And do we have the slide deck up?
Hal, Garrett is going to be loading up your slide as we speak.
And you might want to just give them a little bit of background, if you would, Hal, as we're getting ready to launch this out in terms of, I know we got a lot of questions about how you got interested in the type of things you're doing today, running a mission.
I've always been interested in this kind of thing, although not in missions. Missions are something that I only got interested in recently. I have a PhD in astronomy from the University of Michigan, bachelor's degree in physics from a small school in central Pennsylvania called Franklin and Marshall. I worked initially on the theory of galaxies and then started working on the theory of solar system formation and evolution. So I come from this from a theoretical point of view, which sort of colors some of the things I'm going to say today about Lucy. From the point of view of the impact it's going to have on our understanding of the solar system. So are we ready?
We're ready.
Yep.
Awesome. So as I said, I'm Hal Levison. I'm the Lucy Principal Investigator from the Southwest Research Institute in Boulder. Next slide. So I thought I'd start off talking about the different classes of NASA missions so I can put Lucy in context. There are three major classes of planetary missions. The Discovery is the smallest with a cost cap of about $500 million through development. So that means it doesn't include science operations, and it also doesn't include the launch vehicle. So currently, the Lucy expected life cycle cost is going to be somewhere in the neighborhood of about $950 million. These are all PI-led missions, and they're openly competed by NASA. So what that means is NASA put out a call for people who are interested in proposing a mission. In the case of Discovery, they were open to all ideas in planetary science. I decided we were going to try to propose for that. I put together the team. I led development of the proposal, and we submitted and won. And I'm going to talk a little bit about that and how that worked at the end of my presentation. So, as I said, Discovery is the smallest class. New Frontiers is the next ratchet up. It has a cost cap of about $850 million. Unlike Discovery, which is open to all areas of planetary science, at least the most recent New Frontiers call was limited to the 6 topics that you see listed here. That is, they've just put in their proposals and down selected to a few. And I'll talk to you about in a couple minutes again about what that means. And then there are the big flagship missions. These are directed by NASA headquarters, and they tend to be run by managers rather than scientists. And there are no cost limits to that. An example of that, for example, is Viking and Voyager and Cassini and things like that. Next slide, please. So Lucy, as I said, is a Discovery mission. It's a tour of Trojan asteroids. The Trojan asteroids, as you can see in this diagram, lead and follow Jupiter in its orbit by roughly 60 degrees. The way to think about it is if you calculate the gravitational attraction of the sun and Jupiter, and this is not quite right physically, but it's a good way to think about it, and account for the centrifugal force of the orbit. If you put something directly 60 degrees from Jupiter, it stays there forever. It's stable. And as a result, these guys are a primordial population of objects. Lucy will launch in 2021. We're going to do a rehearsal flyby of a main belt asteroid in 2025. And then starting in 2027 through 2033, we're going to have 5 encounters with Trojan systems for a total of 6 objects, because one of them, and this is my favorite one, is a binary at the very end. So as I said to you before, my focus is going to be on the science and why we're doing this, because that's basically the community I came from. And I'm going to start off by talking about why small bodies in general are interesting. Next slide. So if you want to try to understand how a planet like the Earth came from, what we've learned in the last 20 years about planet formation, and again, I've really made a career of studying how the planets form and evolve, is that planets don't form, if you excuse the pun, in a vacuum, right? They form as part of a complex system where material is being handed off between the growing planets as the planets grow and evolve. So if you want to try to understand how a planet like the Earth came to be, you have to understand how the whole solar system came to be. And I show that in this plot. This shows basically the average distance from the sun in the x-axis as a function of how out around an orbit is. And this is a good way of allowing the structure of the solar system to be seen. So we have the 4 inner planets, the 4 outer planets, and then what I call the small body reservoirs. Next slide. So there they are. And these are really important if you want to try to figure out how solar system formed, because they formed and were sculpted during the formation and early evolution of the planets, and have remained relatively unchanged since then. So in a way, they're really the fossils of planet formation. And if you want to find out what happened then, the thing to do is to go and study these objects. Indeed, Lucy is named after the fossil of a human ancestor in recognition of that connection. So there's the main belt asteroids, Trojan asteroids, and what we call the Kuiper belt, or scattered disk objects that are outside the orbit of Neptune. So these guys, the analogy I like to use, and it's a little gross, but I think it's apropos in this case, is these objects are similar. Well, the analogy is, imagine a bloody murder scene. Sometimes the blood splattered on the wall can tell you more about what happened than the bodies laying on the floor, and these objects really represent the blood spattered on the wall. Next slide, please. And that's why the planetary community has spent so much time and effort studying these small body reservoirs. And we've had missions to the main asteroid belt and the Kuiper belt so far. We've studied comets which come from the Kuiper belt, but the one region we have yet to study is the Trojan asteroids. And that's exactly what Lucy is intended to do. Next slide. So from now on, from the rest of this talk, I'm going to talk about what Lucy is going to do. So next slide. So if you look at the plot at the upper right-hand part of this, and you can see the Trojans leading and following Jupiter. When these objects were first discovered, people just assumed that they were leftovers of the formation of Jupiter. And therefore, we were really surprised when we started studying these objects that they are not a homogeneous population, and that they're physically very different from one another, right? And there's several ways of looking at this. I'm going to focus on 2 here. One is a spectral type, where you look at essentially the reflectivity in the visible and near infrared, and their colors can be used to classify objects in the various groups. In the Trojan swarm, there tend to be 3 different types: D objects, which are very red; P objects, which are sort of red, but not as red as Ds; and then a few gray objects sprinkled in on top of that. Another way of looking at that, if you look at the plot at the lower left, is what we call albedo, which is sort of the fraction of light in different wavelengths that these objects reflect. the visible albedo of Trojans, for example, can be 4%, which is really dark, right, up to around 14%. Right? And that diversity was surprising, given that we thought they were all a single population. Before I want to go on, I want to point out that top bullet, right? Because as I said, I'm a theorist and I tend to think about how these things fit in. But Lucy is really a mission of exploration in the sense that we're going to a population no one has seen before. Not only that, because of their association with Jupiter's orbit, they're not even contributing to the meteorite sample that we have on the Earth. So these objects are totally unknown. Anyway, back to the diversity, next slide. And I think what that diversity is telling us about is about the formation and the early evolution of the solar system. And there are lots of theories floating around. But in fact, I often get the question of why, since I'm a theorist, I'm now doing missions. And the answer to that really is that over the last 20 years, I think our theories have outpaced the data constrained. So we have lots of ideas floating around, but we don't have the data yet to tell which is which. And so going and doing a mission is one way to collect that kind of data. So for example, one idea floating around is called the Nice model, named after the city in France. I'm an author of that, so it's one of my favorites, which is why I'm going to focus on it. But the Nice model envisions that the 4 giant planets formed in a much more compact configuration than we see today. So for example, in the diagram I drew, there's Jupiter and Saturn, in this case, Neptune and Uranus, all within about 13 to 14 AU from the sun. Remember, the Earth is 1 AU, and currently Neptune is out to, at 30 AU. So it's a much more compact configuration. And outside the orbit of the giant planets was a disk of small bodies extending just outside the orbit of the outermost ice giant out to around 30 AU where it stopped. So you can imagine now that these objects varied in color, let's say from gray to red, from the inside out, having to do with the temperature of their formation. The Nice model hypothesizes that this system actually wasn't very stable. Eventually, the orbits of Uranus and Neptune went nuts. Oops, next slide. I'm not controlling this. Their orbits crossed. Neptune scattered Uranus into the inner part of the solar system where they scattered off the giant planets. Boy, this is running really slow on this, isn't it? They barreled into this disk, which gravitationally scattered this material all over the solar system. Most of it got scattered into interstellar space. But as you see, if you look over near the orbit of Jupiter, a few of them get trapped into the Trojan swarms. So if this is true, right, that diversity that we see in the Trojan swarms represents different formation conditions out throughout that outer disk. And so by studying these objects, we can study how those conditions varied as a function of distance. But this kind of diversity is a blessing and a curse, right? It's a blessing because of all the things I've been talking about, of having access to this material that is now gone. Notice there's nothing where the disk was originally at. And so this gives us an opportunity to study conditions in that disk. But it's a curse because in order to understand what this population is telling us about the history of the solar system, we have to study that diversity. And so Lucy is designed with that kind of studying the diversity in mind. Next slide, please. So the way we're going to do this is with this amazing trajectory that we found. A lot of it was hard work by the mission design people that we have, but a lot of it was luck, that all these objects tend to be in the right place at the right time. The planets are literally aligning with one another in order to give us this trajectory. So I'm going to talk about exactly what we're going to do. Lucy is going to launch in October of 2021. Next slide. and we launch into a 1-year orbit. So that way we can use a very small launch vehicle. And we're going to use gravitational encounters with the Earth to pump up the orbit of Lucy in order to get to the Trojan swarms, which are, by the way, that green circle is the orbit of Jupiter, where we're going to be heading. So we're going to have the first encounter a year later. Next slide. We're going to go into a 2-year orbit, come back in, have another encounter with the Earth, and that's going to launch us out to the Trojan swarms. Next slide. On the way back, way out rather, we're going to pass a main belt asteroid by the name of Donald Johanson. Actually, we had this asteroid named after the discoverer of the Lucy fossil. He was really tickled by that. Next slide. And then we're going to go out into the Trojan swarms, the L4 swarms, and encounter our 4 of our targets in that swarm. Now we're going to use the fact that if you put an object, in orbit about the sun, where the aphelion, the furthest distance from the sun, is near the orbit of Jupiter, and the closest orbit to the sun, its closest position to the sun, is about where the Earth is. Its orbital period is 6 years, while the orbital period of Jupiter is around 12. So in the first orbit, we go through the L4 swarms. Now, next slide. We come back in, have another encounter with the Earth, which we use to target our final, guess what, there's one more slide. Encounter with the binary in 2033. And I should say that this encounter this geometry is there forever. So we could use the spacecraft to go back and forth between the L4 and the L5 swarms over and over again. But this is the end of the official mission. After all, I'll be an old man then, so it's going to be time to quit. Next slide. So here are our targets. As I said, we're in the L4 swarm first. We're going to go by 4 objects: Euripides, Ptolemy, Lucas, and Orus. One's a C, one's a D type, and then we have a P type, and then we have 2 Ds. Remember, one of our goals is to cover the diversity that we see in this population, and then go to the L5, where we're going to the binary, which is a P type. So we're covering the diversity. You can see that in another way in the next slide, where again, here are these albedos. Remember, I was talking about the visible albedo on the x-axis, but on the y-axis is actually an infrared albedo at around 3 microns. The blue dots represent the known Trojans, and the red dots represent our targets. So you see we're covering the full diversity of the population. Next slide. Now, in addition to that, we have a couple objects that are really cool in and of themselves. So I want to just spend a little time talking about those. There's 2 I'm going to talk about here. The first is Euripides, the first one and the only gray guy, the only C. Next slide. And Euripides is interesting, next slide, because it's the largest member of the only major collisional remnant it's the largest remnant of the only major disruptive collisional family in the Trojan swarms. So occasionally 2 objects will hit one another at velocities high enough that they break apart. And so you end up creating a lot of fragments, right? You can see these things in the solar system by looking at the orbits of the Trojans. So in the plot on the right, you see an inclination here and eccentricity of the orbit. And if you see where the red dot is, that's Euripides. And you can see there's a cluster of objects just around Euripides. That represents the family. So this is an object that was blown apart in a collision. We've never visited such an object like that before. So it'll give us insight into how the collisional processes that form the planets. Remember, the planets grew from small bodies. So the collisions are key to understanding the formation process. And we're going to visit one of these collisional fragments with Lucy. But that's not the only reason why it's interesting. It's interesting because Euripides is a C-type object. Remember I said that the Trojans are about half P's and half D's with only a little C's thrown in. About 7% of the known Trojans are C-types. So they're rare. So why would it be that the only collisional family in the C-type, in the Trojans, is a C? And I think the answer to that, there's two possibilities. First is that Ds are very weakly bound objects. So when you hit them, they just disintegrate, they go poof and go into dust and they're gone. I think it's unlikely, but it's a possibility. The other idea is that whatever makes a D, whatever makes it red, is only skin D. And so when you break open a D, you see an C inside. And the observations that we're planning to do with Lucy will actually directly address which of these are right. Next slide. So the other object that I want to talk about is this binary. Notice this is really weird, right? This is not like the sun and the moon, right? These are two objects that are almost nearly the same size and orbit to one another. Next slide. And you can see an artist's conception of what that looks like. And the upper right shows a space telescope image of this object, right? And so they're almost equal size binaries, which sounds actually a little strange. And people would have been surprised by this, let's say, a decade ago, until we started studying the Kuiper Belt. Next slide. And this is why this is interesting. If you look out into the Kuiper Belt, the region beyond where the planets formed, remember I showed you that plot at the beginning of my talk, there's a region of the Kuiper Belt left over from the formation of the solar system called the cold classical Kuiper Belt. These objects have never been involved really in planet formation, so they're mainly undisturbed. And when we look at that population, we find that the majority of objects in that population are these near equal mass objects. You can see 3 examples from HST, but in the lower right is an object we just flew by with this New Horizons spacecraft on the 1st of January. And you can see that is also one of these near equal mass binaries. So the idea has been developed that the first macroscopic objects ever formed in the solar system consists of these near equal mass objects. And if that's true, then Patroclus, right, is a remnant of that original population. The idea is that almost all objects were formed that way, but the planet formation process was so violent that none of them survived, or almost none of them survived in the inner solar system where we can get spacecraft easily, except for Patroclus. So it's really exciting. We're going to be able to go to that system. Next slide. So there is our population again. Next slide. There are other ways we cover diversity. So, for example, we're seeing a huge mass ratio between Patroclus and Ptolemy, our smallest object, of around 160 to 1 if their densities are the same. Of course, we don't know their densities. Next slide. We will, but we don't. We're seeing, as I said, Euripides is been involved in a large collision. Patroclus and Menenius are probably primordial. And also Ptolemy is probably small enough that's a fragment of the collision. So we're covering different collisional histories as well. Next slide. Okay, so in order to be able to cover the real estate that we want to cover and get to all the diversity, we have to be moving really quickly through the solar system. So what we're doing is we're only doing flybys. Lucy is encountering its targets between about 5 and 8 kilometers a second, right? And so as a result, the whole encounter, the center part where we're collecting most of our data, is only about 2 or 3 hours long. It's over in a minute. The mission is 12 years, and we're going to be collecting real useful data for less than a day. but we're going to throw everything we can at it to try to get as much information as we can. So we're going to have high resolution panchromatic imaging to do geology. We're going to be able to measure surface color and composition. We're going to be able to measure the Doppler shift as Lucy goes by our targets in order to measure the mass. So we're going to get some densities and measure some information, therefore, about their interiors. And we're going to look for satellites and rings. Excuse me. Next slide. And this is how we're going to do it. The upper right is our spacecraft, right? Let's put that in scale. The high gain antenna is 2 meters in diameter. The spacecraft itself is about 15 feet tall. And from wingtip to wingtip for the solar arrays, which are the blue things, that's about 50 feet. And we're going to have all the instruments mounted on a scan platform, which you can see at the upper right, the top of the spacecraft. There's a close-up of it to the left. We're going to have 4 science instruments on it. We're going to have a high-resolution panchromatic imager called LaLaurie. We're going to have a wide field panchromatic camera on it called the terminal tracking camera, or T2 cam. We have on the right, we have an instrument called the Ralph. It's really 2 instruments in one. One is a color camera called ENVIC, and the other is an imaging, near-infrared imaging spectrometer called LISA. And finally, we have a thermal infrared spectrometer called TESS. That's being built at ASU, I should say. Matter of fact, LaLaurie is an APL instrument, the Applied Physics Lab, which is part of Johns Hopkins, and Ralph is being built at NASA Ames. You can see the wavelength coverage of the instruments at the lower left. Next slide. So let me tell you a little bit about how we got where we are. We started working on Lucy in March of 2014. I actually went back some time ago and did a search for my email with the first occurrence of Lucy, the name Lucy, in my subject. And that's when I got the March of 2014. Roughly a year later, we submitted a 250-page proposal to NASA. The way this works is NASA understands that no one can really afford, without any financial help from them, putting together a document that can prove that the spacecraft can work. So what you do is you do a preliminary engineering and science design to create the step 1 proposal, they call it, which, as I said, is about 250 pages. And you can think of it as sort of like Lego engineering, right? All we did is said, let's take this spacecraft and let's stick this instrument here and let's stick this instrument there and try to put it together in a very cursory way to get something that could work. That proposal went in February of 2015. There were 28 other proposals. Actually, it's 27 other proposals. There were 28 in total were submitted. 5 were selected for further study by NASA. It took them, many months to decide. Each one of those received about $3 million so that we can go and do a comprehensive study of the engineering, which is called Phase A. That started in September of 2015. It ended in December of 2016. What we did during that time is we created what we call a concept study report, which is about a 1,000-page document, right, going through the entire spacecraft from end to end, and also the science to show that you can do what we can do. And then we delivered, think of it as an oral exam. It was a 9.5-hour site visit in November of 2016, where NASA sent about 40 people to come and grill us in order to make sure we actually knew what we were doing. There was some talk earlier about teamwork. One of the things that they wanted to do was put enough stress on our team to see how we actually work together, to make sure that when we got working on this, right, they were confident that as problems arose, we'd be able to handle it. So that was one of the most stressful days of my life. Then we went to NASA headquarters in December. Just four of us talked to the NASA associate administrator about what we were planning to do and why it's so important. This talk you're seeing today is basically what I gave to him. And we were selected for flight in January of 2017. And I've already told you the rest of what we're planning to do here. Next slide. So I just want to put Lucy in some context, right? And we've been studying asteroids in the main asteroid belt for a long period of time. And we learned a lot about terrestrial planet formation from those studies. But in the entire history of unmanned exploration, only 8 main belt asteroids have been studied. And like I said, they revolutionized our view of terrestrial planet formation. Lucy, in one very low-cost mission, is going to visit almost as many Trojans as 6, right? As were visited in the entire history of unmanned space flight of the main belt. And we expect it to revolutionize our understanding of how the outer planets formed in a similar way. So I'll stop now and take questions. Next slide. So Dan, what we did last time was you picked out questions to ask me from the chat. Why don't we do that again?
I can help with that, Dan.
Or Sherry.
That's
Sorry,
all right.
Sherry.
No, that's okay. I was just mesmerized. I never get tired of hearing this story. And I love the last slide. And I know that you also have the Lucy doll from Charlie Brown as part of some of the mascots that you guys have as well.
Oh yeah, and we're Sergeant Pepper, right?
That's
you see
right.
The sky with diamonds.
That's right.
They're the diamonds in the sky. There's no doubt.
We like to have fun on the space missions as well. And this was a technical talk for all of you engineers out there. This was something that we do want you to become cognizant of in terms of the science. A lot of times within the NASA missions, the science or design are driving the engineering design and what needs to happen. And so we're introducing you to the kinds of things that a mission team would come together to have to cobble together. And there may be some language in there, and I saw the chat going crazy in terms of all the explanations. Thank you very much, Jessica and Catherine, to help field those answers. But we want you to become familiar with the kinds of concepts we're going after, even if it's not your discipline. And there'll be times where the engineering is going to stretch the science side of this group as well. So with that, why don't we go ahead and start the Mentimeter, Dan?
We will, and before I put it back up on the screen, so just so everybody knows, you're going to go back to that website, menti.com, use the same code. You'll have an opportunity in a second here to type a question for Hal, but we want actually to see if some of you want to type your name along with that question so we can know who specifically is asking that question. So you can just type your first name, for example, Dan, and then your question. So let's go ahead and try that out. It's not required, but if you want to be kind of called out and say, hey, great question, so-and-so, we're down for that. So let me put that back on the screen. So there we go.
Okay. And while we're waiting for that too, Hal, I was just thinking about, one of the things we mentioned a little bit, but it's the cost cap of what Lucy is spending. Was I right in seeing that it was about 450 million cost cap for the Discovery mission?
Lucy, well, yeah, the current one is going to be closer to 500, which is what I put in my talk.
Okay.
So Lucy was 450 million, and as I said before, that is through development or just through launch, so it doesn't include the science.
Right.
Right, and it doesn't include the launch vehicle.
Okay.
Which is being supplied by NASA itself. So the life cycle cost of Lucy is estimated to be somewhere around $920 to $950 million.
Okay, and as I do the math, in terms of what it costs each one of you out there as a U.S. citizen, it comes to about $2.90 a piece to be able to go out and answer this question that we're dealing with. So, I mean, we don't really think about, oh my gosh, this sounds like huge amounts, but what can you get for under $3? And you can't even go out and get a cup of coffee these days, and yet we're going out to look at things and answer questions that are amazing, that's what it's going to cost you. So anyway, we wanted to kind of put that in perspective as we go on through this, through the Q&A here. So let's take a look at some of the questions that are coming out. Patrick wants to know what kind of questions, when they came and did that stress test for you with that NASA visit or within the proposal process, what kind of questions did they ask you, and what could, what's the type of thing they're looking for?
It was any aspect of the mission, right? And so, they read those concept study report, or I don't think anybody read the whole thing, right? But they came and sort of quizzed us on questions like radiation damage to our detectors, or how errors are propagated in our trajectory to make sure that we can actually target get our, I should have said our flyby distance says there's something like 1,000 kilometers depending on the target. It varies a little bit. How well can you target that? There were a lot of engineering questions having to do with system engineering and how we're going to construct our document trees in order to be able to determine, the flow down to make sure all the requirements are right, that kind of thing.
Okay, Stephanie wants to know, how did you decide what type of scientist you were going to put on your team for this mission? What's that process?
That process, you ask the question. Well, it's an iterative process, actually. So you go to your friends, right? And this is a very small community. And you start talking about it. Well, what would you like to learn, right? About, composition, spectrum, right? The mineralogy. And then start trying to figure out what kind of, whether those answers can be, the answers to those questions can be determined from a flyby mission. And as you start developing that idea, once you decide you can do something, you invite those people to join your team.
Okay, and so a little bit more about that too. Marilyn was wondering, is Lucy inspired by other missions? Is this something that you see things going on and you're adding to the bank of knowledge of something that's an additive kind of thing, or is this a totally unique thing? We want to do this because it's not been done. How does that look?
Well, science is always built on what came before. That's true both in theory and observations, right? And there's no doubt that although I think the Trojans are a particularly interesting population to go to, one of the reasons why I think we were successful, it's one of the few that we have yet to go to, right? Exploration is the key. So of course, we're building on that. And of particular importance, I think, is how the objects we're going to see compare to what New Horizons saw in the Kuiper Belt, right? And indeed, our instruments are based on the instruments that are on New Horizons. I should also point out, on these low-cost missions like Lucy, right, when you write these proposals, NASA wants to see heritage, right? They don't want you to be particularly creative, because the more creative you are, right, the more work needs to be done to convince yourself that it's actually going to work and to build the thing. So Lucy itself is built on basically other spacecraft. If you're familiar with, for example, the Odyssey spacecraft, which is in orbit around Mars, Lucy's structure is based on that. Its electronics are based on InSight, which is now landed on Mars. The instruments are from New Horizons or OSIRIS-REx, right? We built on what happened before. And that's the only way you can make a credible case that you can do it within time and within budget. Okay. Schedule and budget is key.
It is, absolutely. Another question is, what will you learn about, what will you learn from the surface of the geology of the Trojans?
Well, there are things that we know we're going to learn and things we don't, right? If you look at these space missions, the most important thing that ever came out of any of them are the things we never expected. Okay, so that's an important thing to realize. That was true on the New Horizon encounter that we saw just a few weeks ago. Never expected something to look like that. But, you know, we're going to be able to look for things like craters and what the inside of young craters looks like, which allows us to they peer into the interior of these guys. Or the number of craters will tell us about how old these surfaces are. That kind of thing we already know we can do.
Okay, there's a couple of questions out there about the propulsion. Have you chosen a launch vehicle? That's the question. And what type of propulsion do you use for Lucy?
We just use standard chemical propulsion, so there's nothing fancy there. And we don't know the launch vehicle. We have no choice. It's something that NASA is going to tell us. It was supposed to happen the first week in January, but because of the government shutdown, it never happened. So we're waiting. And no, Pluto's not a planet.
Yeah, not anymore. How much danger is Lucy in traversing an asteroid field, and how will NASA pilot Lucy?
No, there's no danger at all. The asteroid belt is low enough density. If you were sitting on top of an asteroid, you wouldn't see another asteroid. And there are many missions that have flown through the asteroid belt with absolutely no problem. And in fact, we're more likely to hit something in our Earth gravity assists, right? Yeah. Something that we put in orbit, than we are of hitting anything as we go through the asteroid belt.
Josh wants to know, what's your average work day like, Hal? What challenges?
I sit in meetings all day.
Yeah.
I mean, it's actually true.
Back to back to back. That's right.
I mean, it's almost back-to-back meetings most of the time.
A lot of moving parts getting a mission
There
done.
is.
Yeah.
Right. And, you know, as part of the leadership team for Lucy, I need to understand every aspect of this. So it's mainly people telling me, right, what they've been doing and how it all fits together.
So you mentioned the proposal that you turned in and you know, went forward with and whatnot. How many people would you say, that was a question on here, how many people actually did it take to put that proposal together? Again, all those moving parts.
That's a good question. I would say that on the first cut at this, there were 10 of us. Right. In December, we had, of this year, we had about 350 full-time equivalent people working on Lucy.
Okay, that's one of the questions that just came by too. You know, so you say only about 10 people actually really were all in on that proposal. Now you're up to 350. So they were asking, there's the same people that started the thing end up with it, but of course you accreted a lot of people since then in terms of getting to where you are in the different parts of the mission build.
Yes, and we've had some turnover. The science team doesn't change. So we're all the same. You know, we've had managers and engineers who, of course, are doing most of the work. That has had some turnover.
Okay, so they wanted to know again, there's kind of a theme going through here. So we're undergrads. What kind of value are we to the mission? And one of the other things that tie in with that, I think, is the length of the mission that you actually mentioned. It's 12 years long in terms of, you know, the length of where you're going to go to the end of the primary mission. So these undergrads are in college right now. What could you advise them to do, or what do you say is their value in terms of doing the kinds of preparation and such that they're doing with the student collaboration?
Oh, that's an interesting question. I think there's a couple answers, different ways of answering that, right? First of all, we're training the next generation, which we're going to need, right? And so it is the longevity of this project that motivates me to come and talk to these people, right? And talk to you guys and let you know what's going on and get you psyched and get you into the field. And on a more philosophical point of view, right, I think that what we're doing is cool, and you all should be thinking about what you want to do, right, when after you graduate, and then motivating you to go and do something as fun as this is part of what NASA is supposed to be doing.
Okay, so talking about, you know, they're just tooling up to become that next generation. How would you say, you know, in terms of the kinds of, again, the day-to-day thing keeps coming up in the questions and what your day looks like. What kind of setbacks have you faced, and how have you been able to deal with those in terms of something not working right, or something that you had to put extra effort into, or de-scope, or, you know, budget issues or something? What are some of the things that you would say as a PI were some of your biggest challenges, and how do you meet those kinds of things?
Well, I think the biggest challenges, there have been two. One is personnel, right? And in a way, I spend a lot of my time just as a glorified babysitter, right? It's very important that people get along. It's very important to create a culture where people feel that they can present their views without getting, without being criticized, and that everybody's voice matters. So that's actually a big part of my job, right? It has been a challenge at times to make sure that that's true. But the technical problems, they're just, as you start digging into these things, you find issues that when you on the upper level you really hadn't thought about before. And so, perfect example of one that we are thinking about now is, it turns out the solar arrays that we have use silicone to glue the cells directly on the arrays, and they outgas during the early parts of the mission, and they could potentially be coating the optics on our instruments. So that's one of the things we're trying to figure out, what we need to do to protect the instruments from that outgassing. It was just something no one thought before, because we hadn't thought on that kind of level. So those are the kind of things that we need to worry about.
Well, I heard you say it a couple times now, that the thing that is the most surprising are the things that you're not expecting and you couldn't forecast, that you have
Right.
to deal with on, you know, when they come up, then you have to kind of triage, problem solve, figure it out, and go forward. So this is not a cookie cutter mission. These are things that you're trying to do that have never been done before.
That's absolutely right. And even though it's based on missions that have gone before, it really is a unique beast. And we're going to a unique place with its unique environments, right? For example, it's going to be, all these instruments are going to be running at a colder temperature than they have before. Even the ones that are on New Horizons, it turns out they're inside the spacecraft. And so they're actually warmer than our instruments are, that are sort of hanging out into the breeze. And that's been a technical challenge.
So we have Veronica wanting to know, will Lucy shed enough light on the theory of the D going into the C-type asteroids to where that will be something that you'll be able to really understand a lot better?
Well, we certainly, that's the plan, right?
Okay.
We don't know what we'll see, so we don't know if it will, right? So, but certainly the observations we are planning to do were designed in order to try to answer that question.
And to highlight that, you know, this proposals that are done are very scholarly. You have all these top experts that are theorizing these things, and they're not going out with questions that are flimsy. These are very solid questions that they have a good chance of being able to determine, but you don't know till you get there what the answer is going to be. So that's kind of the way science works, is
Yep.
More information helps you understand that. And Connor wanted to know, will we learn enough that this will satisfy with the flybys you're doing on the Trojans? Will this satisfy enough to know about the Trojans and say, we kind of bagged that and it's done? Or is this going to actually ask for more reconnaissance later?
I think the likelihood is the latter, right? Just by looking at the history, right? These missions are, they're really twofold, right? The first is to ask and answer questions. The second is to discover new questions to ask. And that typically happens with these missions. We see something we didn't expect, think of Pluto, right? And that forces us to go off and ask more questions. Sometimes we can answer them with ground-based observations, sometimes theory, but sometimes we need additional missions. But that's the way science is done.
Okay.
And if you don't mind me saying, right, that's what you want, right? Or that's what I want.
Yeah.
Right. What I love to do is to discover new things. Once we discover it, it becomes less interesting to me.
So I know this is one of the things that you showed on the slide that was really interesting, and they wanted to know, so how did you work out that incredibly complicated trajectory of all those visits? What did that take, and what's the best way that you can explain how that was done?
Yeah, well, I didn't do that. Believe it or not, there is a field within this community that do nothing but mission design. And so they find these amazing trajectories. What happened in our case is we started off small, right? I wanted to go, the Euripides was the only target on our list that I said, I want to go there, and then built it up from there. And a lot of it was just luck, that we happened to be able to get to, for example, the binary, at the end of the mission, right? We discovered that simply by, we were looking at whether the spacecraft would actually hit Mars, which is something that NASA does not want to happen because we don't want to contaminate it, right? And we just happened to notice it was flying by Patroclus. It's that kind of thing.
So who's building the spacecraft?
Lockheed Martin in South Denver.
Okay, so it's being done just in your backyard there.
Yes.
Next to Boulder. And how's the data being sent back these large distances, and how much data do you expect to get over the lifetime of the mission?
Oh, that's a good question. Not a lot by modern standards. A few tens of gigabytes of data is all we're going to get down. And remember, I showed you that high gain antenna. It's a 2-meter antenna that's on the spacecraft, and that'll beam the data back to Earth very slowly. It's going to take months to get the data down. And there's a series, we call it the Deep Space Network, of radio dishes spread through over the Earth that will be listening to it.
I've got 2 more questions. What was the biggest obstacle in the mission design that you had to face and solve?
To do something as complicated as this within the mass limitations that we had, right? That was basically keeping it lightweight.
And that's probably something that most missions have to deal with in terms of mass constraints.
That's right.
So the last one is from, I think it's Tina. Let me get here real quick. And she wanted to know, what's the favorite part of your mission? We're going to end with that.
What's my favorite part of my mission?
It's kind of like saying, who's your favorite child, Hal?
Right? Or ask me my favorite child, right?
Yeah, exactly.
Right? I mean, look, the one thing I will say about this, right, is if you're going into this field, there are 2 aspects of being a success, right, and enjoying yourself. The first is you have to think what you're doing is important and cool. The second is that you have to enjoy the process of doing it. So I know, for example, several science writers who started off getting into the field thinking they would be scientists, but actually didn't like doing research. And so they went off and did something else. Not only do you have to enjoy the science, you have to enjoy the process of doing the science. And that's from a scientist, but if you're an engineer, which most of you are, it's the same thing. You have to not only think the spacecraft is cool, right? You need to enjoy what you're doing every day. And they're quite often different things.
So we're going to end with that, and I'm going to answer a few more questions too. Giovanni, if you want to put your, I see you have your hand raised, put your question in the chat, that would be great. We want to thank you, Hal. We know how busy you are and how crazy keeping this thing moving forward and getting it to the launch pad. It's going to be launching in October 2021 from Cape Canaveral by Kennedy Space Center.
Yep, 1,003 days from now.
All right, and you probably know down to the hour on some of those days. You started out, you know, as a very dark bearded man, and now.
Oh, that picture was very old. I've been gray since my kids have been.
All right. Well,
thank you.
This has been a fantastic time, and thank you for coming and spending this time and giving us this overview. I mean, Lucy is going to be an amazing mission. We wanted to kick this off again because we are through the graces of the Lucy mission and the Lucy Student Collaboration and Science Mission Directorate, we're able to have this academy. And you are part of the Lucy family. The questions that keep coming up saying, so what's our part? What's our role in this mission? And part of that is the future workforce that we're getting ready for Lucy and other types of missions within the Science Mission Directorate. But also we have opportunities for you to become a Lucy ambassador. That'll be explained later, where you can actually be connected with the mission as an official representative in terms of sharing things with others. And so we want to be able to give you the chance to learn from the experts and hear the stories as they're talked about. So we do have some things that we'll be talking about in terms of sharing slides and doing all those kinds of things as well. But being here in real person versus recordings, and I know a lot of other types of activities. And before we start, let me just stop for a minute. I see some of the thank yous, but let's thank Hal. Again, for him to spend an evening with us, and after a very busy, long days that he has to put in, we sure appreciate having someone of your caliber actually come and share the story of Lucy. This has been something that's been phenomenal, and we are very privileged to be able to have the head person here telling us exactly how this is going to go. So we thank you very much.
Hal, the chat's blowing up with a bunch of thanks, so thank you.
Yes, it is. So from that, again, we have other opportunities. We want to be the people that help not only giving you some of the training and practice in which you will have a chance to be wrangling down some concepts and hard missions of your own within the teams that we're going to be putting you on, but also helping to connect the dots of what else NASA has going on and what other opportunities there are. Giving you the chance to make sure you're hearing about the latest things, the opportunities. We'll have meetings of opportunity at places like the Lunar Planetary Science Conference that's going to be in Houston in March. We'll have, you know, the places that we end up coming, we're going to make sure we highlight where we're going to be to where we can meet you and have a chance to put a personal greeting to the people that we're seeing online. This is a family that we consider this family style in a professional way. We want you to, number one, not be stressed that this is adding a lot of stress to your life. This is not the purpose. Your job one is to graduate and to further your degree, and school is important. So this is not to be additive in terms of something that you're stressing out. That's not our intent at all. And if you have questions, we have our full team here to help you through those places that maybe you don't understand. There are no stupid questions. This is the place, the safe place that you get to actually ask and learn. The other thing that Hal mentioned is so important is that we need to be inclusive. This is not a, I'm in charge and you all listen to my idea and that's what we do. That's not the way mission teams work. And it talks about how, and research shows, diversity adds to the optimization and the success of the projects. So being inclusive in the way that you're setting up teams, and we're going to give you, we're going to introduce this next meeting, next session in a week from now. We're going to be talking about, here's your toolkits, here's methodologies that are really industry standard and professional types of practice that we want you to be able to have and be able to start these things now. And these are the kinds of of tools and skill sets that's going to get you hired coming forth into your career pathway. So we want to, again, emphasize the things we know from being within the missions already, the kinds of things we've collected data on in terms of what the hiring people and what the teams are saying we need desperately, and what's going to get you in that higher, more marketable category at the outset of this in terms of what we finish. So with that, I think there are a couple more data points I wanted to get before we end tonight. Dan?
Yep. So one last mentee with this particular code, and some of you have already started filling it in, but we want to know, just kind of get an idea of which areas of NASA interest you most. We'd love to customize and personalize the experience for you, and I'd like to get to know you better.
So these are some of the things we've put in that we have seen as some of the highest interest points from other types of surveys. We just wanted to kind of see where your interest lies. And this is helpful information, but it also kind of gives us an idea. And so far, I mean, a lot of the things we're looking at here, we're going to be touching on, so we don't have a problem at all with these kinds of themes. And if you're hitting other, why don't you put in the chat what other means?
Yes.
Just to kind of help demystify that for us as well, if you are one of those 5% that are putting other. Numbers are holding pretty steady there. Okay, medicine. All right. Solving mysteries. Deep space exploration. Okay.
Astrobiology.
Propulsion. Some of those are going to be building spacecraft and whatnot.
Mm-hmm.
Got a lot of people that want to build spacecraft. That's really good. So we're going to be putting you to the test here within the project. I think you're going to be pretty excited. Kevin, if you've got a question, why don't you go ahead and put it in the chat? We're trying to drive people to the chat because we'd have 450 hands raised if we tried to do it the other way. So we're gonna try and push it the other direction in terms of having it to where we can record the chat and we know what's going on. And we're gonna take the questions too, and we're gonna take the ones that maybe we didn't get to with Hal, and be able to build an FAQ with just from the session with these different presenters, and be able to answer some of those questions too. So thank you for inputting those questions. And again, we're trying to pull out with the time that we have the highlights and things of being able to pick the brains of these amazing people. So this is kind of the way that we're going to be doing. All right. And then we also had another one, Dan, and I want to be cognizant of time about the timing.
Spring break is the next one. So what I'm going to do though is I have that on a separate code. Let me pull that up briefly.
We're wanting to make sure that we're going to probably do a 2-week session break to allow people to be at spring break and not be missing in crashing into different things. So we're trying to look to see the places where you all can help us inform the most advantageous time to take that break. So that'll be helpful. Appreciate it.
I've actually put a pretty wide spread there just to give some options.
Yeah, we know that different universities have different schedules, but we didn't want to plan it, for instance, what ASU's break is. We wanted to plan it to see what we can do. We will try, if it's a widespread, we may not be able to satisfy everyone, but hopefully since we're online, maybe you'll take a little break from your vacation just to log in for that hour and a half and catch up with us. So right now it's looking mid-March, which is traditional. So we'll take a look at that as people have inputs. A break from vacation. Well, sorry, did I say that? It's because I'm pretty sleep deprived tonight, I think. So we work pretty long hours here too, trying to keep things going, especially getting ready for the start of the academies. We're pretty excited. So yes, Caitlin, we do work with Space Grant. In fact, we're partners with NASA Space Grant in terms of the national at NASA headquarters, we're part of MURUP, which is the Minority Universities research group, and then also with Space Grant. I'm actually a Space Grant product through my undergrad. I actually was awarded Space Grant fellowships and such, and so I know all about Space Grant. And it's another opportunity that everyone has within their states, and that would be an opportunity, one of those dots that I would absolutely tell people to look up what it is available within their states and the scholarships and fellowships and projects that they have available. It's a great organization, and it's available across the U.S. So that's another important thing. All right, so we have some good data here. We'll capture this. And I think we're just going to get ready for next week. Again, we're going to be announcing the teams. You're going to have a chance to meet face-to-face with your team. So if you didn't have a microphone this time, I would encourage you to make sure that you do have a microphone next. And here's one last Menti question.
Yeah, I added this one actually just right now because we can actually leave this. If everybody keep the code after the session is done, if there's any specific questions that you have for us that we can go back and kind of look as we're building up this FAQ sheet for you and get these questions answered for you, we can do that. So I'm not going to leave this up for more than 1 minute. So everybody get the code, and then I'm going to stop.
I can see a theme here already. Teams are between 8 and 10 generally.
Yeah.
And so, no, you cannot request a team member because this is like a job where you show up and you're not at work with all your friends. So we're giving you practice into not just hanging out with your buds, but we're going to actually say, here's your randomized team. Here's your, what you're going to be doing. And this is really, I think, one of the things that the last Academy really came away with on how really helpful it was to actually learn to work across different types of groups and personalities and ideas. And this is one of the things that's come out the strongest in terms of the value of the teamwork that they did. And so we, not to scare you off or anything, this is something that we want you to experience in a positive way, not, oh gosh, we have to do group work. That's not it at all. This is not that kind of thing. This is a project that we're going to be helping you and getting you ready for that workforce experience. Okay. All right. So have we anything else on our dockets tonight, Dan?
Not really. I think we've got it all. And like I said in the chat, the questions are still up in Mentimeter, so you can continue to add those. We'll leave that open throughout the rest of the evening. Obviously, you can contact us if you need to via email. Feel free to email me directly, and I'll get back with you in a timely manner. Somebody asked something else in the chat and I missed it. Oh, the email will be in your inbox in approximately 2 minutes. It's scheduled to go out at 7 o'clock Mountain Time, so it should be coming in shortly. So more information about the internship is there as far as which organizations, if you're selected, you might be at. In terms of compensation and the link, more importantly, to get your application in right away. We'll tell you ahead of time, if you're planning on applying, here's a couple things you need to have in advance. Have your resume ready, have your transcript ready, because you'll need to upload both of those.
And it could be not professional, not the transcript.
Unofficial
transcript. Yes.
And also have the name and email of somebody that is going to write a letter of recommendation for you. So I'd advise you to reach out to that person and ask them if they can be that person for you, because you'll need to include their name and submit your application. Once you submit, they'll get triggered an email that will prompt them with instructions on how to submit the letter for you. So it's very important you follow step by step everything the application says. Mainly the very first thing that says update your profile. There's a link there. So you'll have to create a profile, make sure your first and last name are correct, and you click that link to do that. If not, your recommender won't be able to upload the letter.
And as far as some of the details in terms of full-time status, U.S. citizen status, GPA, all of those are on the NASA website for the internships. We have the capability, NASA asked for a 3.0 U.S. citizenship. We know that there are non-U.S. citizens that are coming to U.S. Universities. We have that down. Everyone's allowed to apply. in terms of the Lucy's internships, but the considerations will be depending on where they're going. So the internships are listed on the page in terms of where the players are. Some are at NASA Goddard, some are at Southwest Research Institute where Hal is, some of them are at Arizona State, Kinetics, and Lockheed Martin. So those are the 5, and some of them have specific rules and others don't have as stringent rules. So we abide by those. So I would encourage everyone to apply. Just the practice of application is really good. The last thing I'm going to do as we hit the top of the hour is I want to again stress the idea, and I know spring semester especially is stressful. We want you to understand that, you have to learn that you're not alone if you're feeling stressed. We're always here in terms of questions and help. There's no judgment at all if there's things you don't understand or you just need more help on. This is why we are here. And this is this is more of, it's not sink or swim. We want everybody to finish the race, and we want you to finish strong. So team-wise, questions, personal stresses, again, don't just be out there by yourself. This is important for you to understand that you're not facing this alone. This is something in which we're providing that support structure for you. And we want you to reach out if there's any questions or there's, occurrences that you're hitting, as one student put it last session, rough patches. Don't ever feel like you're alone. All right. That's just one of the ending things that I want to put out there. This is something we're going to be through the next 12 weeks. We hope that you really will enjoy this ride. It will be challenging. It will stretch you. It will be painful at times, sometimes, but I think the overall gain that you're going to get out of this experience is going to be well worth going all in.
Yep.
So with that, I think we'll be ready to say good night. And again, we are looking forward to the next 11 weeks with you. All right. So good night.
Good night, everyone. Thank you for joining us, and we'll see you soon.